Hello, thank you very much for inviting me to give this presentation here. What I'm going to talk about is basically a little daemon that I wrote back in January. So we all know the internet is not a very safe place to be. I mean, every time you plug, somewhere in some network and you open some ports, you're immediately opening yourself to attacks. Is IPv4 safe? Yeah, for the most part. If we sit behind NAT, we're okay, and we don't expose services. But there is also the UPnP problem that, you can actually access, if your router is configured to do that, you can access machines inside. About IPv6, well, you're kind of more of a needle in a haystack, and people haven't started attacking IPv6 yet. At least I haven't been seeing any attacks on SSH. I have seen attacks on the name servers, though, which is kind of strange. So how do you know if you're under attack? Well, you can watch your logs, and that's how I found it first. Basically, I wrote this because I got really upset that my logs were growing to be gigantic. I was being attacked continuously. The performance drops, but not really. I mean, the only case that you're going to see performance drops is if you are in a low bandwidth network and somebody is really congesting your link, because the CPU is like really fast these days, so there's not going to be a significant penalty. And then you can just sniff the network. So here are a sample of my logs. I mean, you can see people are constantly trying to break via SSH, and then they're trying to poison my DNS. And also what they're trying to do, which is kind of strange, is that they're trying to write to my zones. So but that's kind of stupid. So I wasn't really worried because I have configured SSH, with no password authentication, and although the bind server has a lot of security vulnerabilities recently, I haven't really worried about that. So anyway, I was worried about other daemons too. So the problem here is that each daemon feels free to either do things by itself, mitigate the attacks like Postfix does, or like Telnet, it never just responds, or it never logs anything. It just keeps going. And then there are other daemons that either log or don't log, and I don't know. There's no consistency, and unfortunately, there's no way for those daemons to tell the administrator, I'm being attacked, to make that kind of visible. The only way you can figure this out is through the logs. So I said, all right, fine. Like, what am I supposed to do here? Well, you can move, the port that you're listening to on some services. You can reconfigure your name server so it doesn't respond. You can use TCP wrappers. You can use your packet filter to block places. Or, there are other popular packages out there that let you block selectively things and dynamically. So I said, that's cool, I'll try those. So I looked around, and basically the three more popular ones that I found basically is SSH guard, fail to ban, and deny hosts. They all have something in common. They just scan logs, and they try to figure out from the logs that they scanned what to do, who to block. They have like elaborate parsers, and they all have like different implementations. They support different filters. They're written in different languages. Some of them are more configurable than others. Some of them have better performance than others. And finally, some of them support even a distributed kind of approach to blocking, where you can send centrally the list of attackers to a database and get back that list and block things by yourself. None of them support IPv6 right now. So I didn't like that too much. I mean, I don't think that parsing logs to do this is a very good idea. It's expensive, and also, in order to do it quickly, you need to unbuffer your logs, because you don't want to wait a while before you start blocking. Sometimes you get a host name, sometimes you get a partial host name, sometimes you get an address. You have to figure out what it is from the message. And then it's dangerous, because first of all, these things use regex to parse, and they can actually cause problems because regex is a very expensive and difficult to secure operation. Also, formats change, you upgraded something, it's logged with a different set of words, the error messages, or files move around. And for every daemon, you have to customize and write a new parser. So also, users can actually use logger and send messages and cause denial of service attacks to your syslog. And we don't even have enough information. Basically, we wanted to be able to say, this packet came from the internal interface. It's somebody who I trust that was testing something. I don't want to block him. But if we have no way to tell. Anyway, so the problem that YSSH failed to ban and the rest of the programs, they started with a fixed solution that programs log, and this is the only information that we have in order to block an attack. So what if we could start over and modify every daemon to actually do something, tell us that they're being attacked? So, that sounds like a really bad idea. Sometimes you don't have access to the source. Sometimes, touching the daemon requires extensive programming. But I was really upset about the fact that I didn't want to parse logs. So I said, how bad can it be? I'm going to write it. And so I did. So I tried to make the change as simple and transparent as possible. So right now we have this kind of situation. You have like daemons that log to syslog, which logs to files, and then fail to ban scans those logs. Then we have daemons that have separate log files, and then again, fail to ban scans their logs, and then fail to ban talks to the packet filter and adds and removes entries from the ACLs. So I said, OK, so what if we let the daemons alone and we added an extra line to each one of them to also tell me when things go wrong that they're being attacked. And then that dedicated daemon can deal with the packet filter. The advantage of this is also that you end up not timing out entries because you can also get both a positive message and a negative message. Basically, I'm being attacked because somebody typed their password incorrectly, but then he typed it successfully. So now it's OK. So I can unblock that IP. So I saw, and syslog is a very elegant program, although it's ancient. It uses Unix sockets. And Unix sockets are very neat because basically they are not blocking, but they can lose packets on UDP. They're simple to use. Unfortunately, we need multiple endpoints because daemons chroot, and we need to make the presence of the sockets in multiple places in the file system inside the chroots for the daemons, but that's simple. And we have file system security, but as you'll see, that's really not needed. It's like the syslog socket, anybody can write to it. Same with the Blacklistd socket, anybody can write to it. The protection comes from elsewhere. So how does the API look? Well, you have to know if to block or not. So it's a 0 or a 1. You have to know, your local address. And you want to know your local address. Why? Because this is how you authenticate that the daemon has the right to block that port on your machine. Because otherwise, anybody could go in and say, block port 22. That would be bad. So then you want the remote address and a message. A message is optional. But how do you really trust that the daemon passes you the right information? Well, it's very simple, because actually in Unix sockets, you can do file descriptor passing. So instead of passing the addresses, which is clumsy, you just pass the file description of the connection. And then what we can do, we can use getSocketName to get the local part of the connection, and we use getPeerName to get the other guy from the other side. And getSockName can't lie, because it's given by the kernel. And also, it makes the API much neater, because I don't have like 6 arguments or whatever I had before, but I have just 3. So the full API is, the TCP case, which is pretty simple, as we saw before. UDP, though, it's a little bit problematic, because in UDP, since we don't have a connection, we don't know the remote side. So the program needs to give us the remote side. And then, for efficiency, instead of like opening the socket every time a new connection comes, you can just open once and get a cookie back that keeps basically state that your program can use to send messages without opening and closing all the time. So this is basically what it is. So again, borrowing from old Unix configuration files, the configuration for Blacklistd is like very familiar because it's exactly like inetd. So you give it basically a port and a socket type, a protocol, which is whatever. You can wildcard everything if you want. And then you can give it a number of failures that will trigger blocking and the amount of time that these settings will be set for. So basically that says that if you connect to my machine, and you can try to do it right now, if I give you the IP address, and you try 3 times and you don't get in, then that's it. For 6 hours, that IP address will be blocked. This is what this says here. And so for these 3 entries, we have SSH, we have FTP, and then we have the name server. So you can make things more specific. You can say, okay, fine, for my internal interface, I never want to block. So you do that. And then when it matches that it's coming from there, you don't match, you don't block. And then if it comes from any other interface, then you do the default action. Also, you can be more surgical and add a local and remote parameter. And the remote parameter basically tells you how to deal with the remote side. So, for example, the first entry whitelists all of the class C at 38.17.134. And that means that none of the above rules will match for this one. It will always let things through. The second one says, well, this network is bad and they keep attacking me, so I'm going to put a /24 rule instead of a host-to-host rule, so I'm not going to have a lot of rules inside my network. So, for example, if I saw many machines attacking me from this class C, I would just put a /24 rule there so that I would get 1 rule if any machine gets me, instead of getting like 10 or 20 or 30 rules. And then, the same thing works for SSH, and you can see the V6 rule is basically, you can have differently named rules. The notation equals means do the same thing that the local side does, and the star means use the default values, which is in the clear mostly. So how does it look for code? So the example I'm going to give is SSHD, and basically you make a little header to make things neat. So you have an init function to initialize the packet filter notification mechanism, and then you have a notify function which takes an integer, which is either 1, which is block, and 0, don't block. And the code for pfilter.c for SSH is this. So in the initialization code, you just keep your state and call blacklist open. On the notify, basically, you check if the state was not initialized and you initialize it. And then basically there's a function that says packet connection on socket, which is an SSH function. And then you use that function to get the connection. Otherwise, it's the next descriptor after standard error, so it's 3. And then you call, that's where the connection is. And then you call, the blacklist function to either block or unblock. So here is the code modification for SSH. This is the one place. So you include the header file, and you say that if the authentication wasn't postponed, which means if the authentication is happening actually, then pass if we're authenticated or not. So then you can also do the same thing for timeouts, because that's another mode of attack that you get. So people just open sockets and let them time out, so you can have a lot of connections that are pending idle. And then you do the same thing there. So what does the daemon do? Well, the daemon maintains a database file of all of the connections that it has seen and the ones it has blocked or not, together with information about the rules that it has sent to the packet filter, so it can restore. It parses the configuration file, which I've shown before, and then handles requests. And then I decided that the easiest way to communicate with the packet filter is to use a shell script. And that makes it very portable across different packet filters, because you can just put whatever the commands for your firewall are to add and to block and unblock inside the shell. And here is the shell script. So this is written for NPF, which is the NetBSD packet filter, and it's basically quite simple to understand. So There are 3 commands you can have. It's add, remove, and flush. And the add adds the rule with the parameters. The remove uses the ID that the add returned to remove the rule. And if you didn't have a packet filter that had the ID kind of feature in it, you could just pass, remove, proto $3, $4, $5. It will pass you the full information that you use to add, so it's completely symmetric. So this is basically my firewall configuration. That's the full thing of it, so that I don't do anything. So I pass everything, and I just have a rule that's called Blacklistd that NPF adds and removes rules to, and that's what gets the configuration going. And here is like a status. So there's a command to dump the entries. So you can see that there are 3 entries here, 2 of them on the bind port, 1 of them on the SSH port. This is the rule ID, 4FC, 47, whatever. And it's, of course, it's 3 out of 3 failures. That's why it's blocked. And here is the remaining time to unblock them. And the last one has only 2 entries. So the guy hasn't tried for the 3rd time, so it's not blocked yet. But if he tries again, we'll see it. And then this MPF command shows you the rules that are currently active in that rule set. And here is what Blacklistd logs every time it says blocked or released in messages, so that you can get a status of all of the activity. So this stuff has been ready since January. I've been running it on all my machines, and it works really well. I haven't really done anything. It just runs, and my logs are much shorter, and I feel very happier. I ported it to NetBSD 7. It runs on NetBSD current. It compiles and runs on Linux and Mac OS X, although I haven't done any testing with the firewalls to see if, I don't know what, I'm not running Linux, so I haven't done it. And I have patches in the source tree for bind, FTPD, and SSH. And in the, whatever, how many months? It's like 9 months I've been running it. In the beginning, I have hundreds of entries in my logs. And right now, I have like 3 or 4 on each machine. And that means that the attackers are also intelligent, and I think they're giving up. They're not like really attacking me like they used to. Yeah, that's what I was saying. Yeah, so a handful of people, NetBSD people, run it. Hopefully, more people are going to use it when it's released. Ideally, I mean, I want to run it with enabled out of the box, because it's not really hurting anything, and it's making life a lot simpler. And I want to convince people to just try it out. It's a very portable code, I think, and it's auto-configured, and it should really work, but we'll see. Anyway, thank you very much.
I have 2 questions for you. The first of which is, you can tie rules to particular interfaces. Do you deal with multiple IP addresses on those interfaces?
Yeah.
And also, do you
But
deal...
you can't say both interface and IP address. So the rule has to be either an interface or an IP address. So if you want to do it by IP address, you just give the IP address of the local interface. So basically, if you have 3 addresses on your local interface, you can explicitly list an address to have an address-specific rule, or you can you list the interface, and you get all 3.
So, and do you do anything to monitor IP address changes on an interface? So like if you're using DHCP?
I don't remember. I think I do. Yeah. Yeah, actually, I have. The problem is that if you, I don't handle add and removal of interfaces, because the rules don't handle it, but the rest of it should work. Yes?
Have you thought about having multiple Blacklistd instances communicate, so you could have, if one host sees an attack, other hosts on your network could also block that IP?
I thought about it because, as I mentioned before, there was one other program that was doing that already, so communicating state. But first I wanted to get something that was simple and standalone. I mean, in the future, I haven't even thought how to do this. If I should do it via having Blacklistd itself doing the communication, or having another daemon that monitors the database and synchronizes it across hosts.
I'd just like to make you do more work. It occurs to me that you've done a nice thing here, but maybe split it in two, create a sort of standard for logging of attacks, and have this program contribute to that, but then other people could, be listening in the same way for the same things and not have to track your code base.
Okay. I mean, I think that adding a notification mechanism in the configuration file would be very simple. Basically, to make it to run a command every time something happens on the daemon.
Yeah, but I'm suggesting maybe move from Blacklistd version 2 or anti-Blacklistd or some
Yeah.
something else that doesn't have to import much of your code.
Yeah, no, if you look at the code, and you can just go ahead, the majority of the code is parsing the configuration file. Yeah. The rest of it is trivial.
I'm the maintainer of SSH guard on FreeBSD, and I'll happily say it's a terrible idea. It's the best of a bad tool, a bad group of tools. I don't think anybody's throwing fuzzers at these things, but I'm sure, SSH guard being written in C, there's all kinds of fun things in there. I wouldn't be surprised if someone out there is trying to exploit the daemon through crazy log entries that they're creating. So I really like this design. This is great. What do you think the chances are if we get multiple BSDs using this thing that we can get some of these patches to these daemons upstreamed?
It's up to the maintainers of the daemons, but sure. Yeah, I mean, if it becomes successful, it will be something like, I look at it as, TCP wrappers. This is like a dynamic version of TCP wrappers. TCP wrappers were adopted by a lot of daemons, and it was a if, def, wrap, whatever, and we can do the same thing here.
Right. Yeah, and also none of the other tools, like you mentioned, IPv6 isn't supported by them. They also don't have any concept of subnet masks, so you can't even configure them to block entire subnets. Mm-hmm. Instead, you end up having to tell your network admin to black hole them or something. And so, this approach is really great, and I'm hoping that other people will look at it and try to get it imported. So,
thank you very much.
Thank you.
So just to follow up on the question about standardization of IP blacklisting, whitelisting, and exchange of information, I would like to mention that there is an ongoing effort under Oasis to standardize such a thing, including the transport protocol for it. It's called STIX and TAXI. STIX being a superset of cybox defining indicators of compromise, and then TAXI being the transport protocol for exchanging this information over. And this is currently ongoing. I think they have version 1.0 out, 2.0 being prepared for each of these standards formats. And reference implementation is in Python, and the protocol is using either XML or JSON.
Okay, thank you. All right, thank you very much.